business. All right, a very quick introduction. First page, please, Stefan, just to get the official part out of the way. So my name is Fritz Woller. I have about 30 years automation engineering experience under my belt. 20 years with IS Systems, for that matter. IS Systems is a partner of the Regional Profibus Association. We are a member of them, and we're also the Indusol partner for Australia. So we represent Indusol and their equipment here in our market. And that's really all you need to know about me, to be honest. Your presenter for today, the good-looking gentleman in the left-hand corner of the screen, is Stefan Fischer from Indusol in Germany. So good morning to Germany. It's 7 o'clock in the morning. I hope you had a good cup of coffee, Stefan.
Yes, I have. Thank you.
Stefan is the head of training at Indusol and has been doing that for well over a decade, and pretty much knows everything there is to know about all sorts of industrial networks. And that is it from my side, and I'll hand over to you, Stefan. Take it from here, please, and thank you very much.
Okay, thank you too. So, okay, let us start with the first slides. I will show you today what are the reason or what are the main things in the troubleshooting in PROFINET, what means PROFINET and what means the quality parameters behind that, how do you can measure by your own, or how you can find out the quality in your own network, and how do you do permanent network monitoring, or how we say it here, 24/7 network monitoring. But let us start directly to our vortex analysis. Our analysis will show you what are the main problems or the reasons for troubleshooting in our business. We do a lot of services around the world, and here in this chart you can see what are the main problems by the client side. And you see the top three are here: the performance and the physical things like cables and plugs, and the EMC part is one of the other big issues in our network troubleshooting. How it looks in the past, I get also this charts from the last 3 years here, and you see we every time the physical part of the issues are the main problems what we have by our troubleshooting. But you have to know, in this vortex don't show us the only Ethernet based troubleshootings. All other troubleshootings are in this charts. That means Profibus troubleshooting, CAN bus troubleshooting, RC bus troubleshooting. So we have a lot of classical or a lot of troubleshooting in classic field bus systems here additional in these charts, and this is why we have so much physical issues. You work with a classic field bus system like Profibus, RC bus, CAN bus, and so on. You have, or normally you can say 75 to 85% of all issues are based in the physics, and only 10 to up to 25% are in the logical side. In the Ethernet-based system, it's switching. In this case, or in this situation, if you work with Ethernet-based system, only 10% are physical issues, until up to 90% are logical issues. But what means physical and logical issues? This is what I want to show you in the next slides. But first, some impressions. What means EMC? Here I have a nice picture for from an EMC troubleshooting. In the switching cabinet, everything looks fine, but if you look underneath or under the switching cabinet, you see wirings like that. But you have to say you have a good protection in EMC by the field bus system itself. That means you have a shielded cable, it's twisted pair, or it's a star quad cable, or you can say you have a voltage differential signal, and this means you have a good protection, but sometimes it's still enough. It's not enough if you have a lot of leakage current or potential equalizing current. So what else? Here, for example, here you see a PROFINET installation very closely to the motor cable or power supply cable. And normally you can say you need, or the normally you can say you need a distance between 10 to up to 20 centimeters to have a protection between cables like that and like the data cables. And here you see, from a practical side, how it looks sometimes. The other thing is the grounding. You see here, this is an old plant from Austria. The people, don't take care of the normal grounding system, and here the basement of your EMC protection was not good enough here anymore, and this is why or you can find some issues like that on the plant side. Later I can give you another examples, but this is only for an overview to come deeper in this topic. If you have some question, you can write it down every time, or you can ask this question in the end. How do you like? So cables and plugs, here you see some Profibus installations. You see a bad connector here in the water area, and so this has a good patina out of it, and this is not a good installation. The same thing like that. Here the wires, or the wires outside the cable have no good sheet protection. They are too long, and so this is also not a good installation. So what else? Here some other examples for a bad installation. You see in this picture, you can see we don't use a right Profibus cable. This one is a Profibus cable, but the gray one is not a Profibus cable. So this is also a bad thing because of the impedancy of the cabling. And here the same, the normal Profibus wire don't have enough protection against some installations like that. So another issue what you have now in, or what you can have, or what in our top 3 of our client side issues are performance and packet loss. And here in this picture is a chart that you can see. If you have a higher net load in the system, you get issues with packet loss. So that means the devices are overloaded, and because of the overload of the devices will discarding some frames. But how I said, this is only an overview. I give you later some deeper explanation about this kind of issues. So how I said, these are our top 3 of our issues what we have on the client side from 2020 and also 3 years ago. And I think in the next also 2020 we will 21 we have some charts like that, and the statistics is the same, because how I said, we have still a lot of classic field bus systems, and Ethernet based systems are growing up. So maybe in the future the performance issue will get on place number 1, and the cable and plugs issue will go down to position of 3. So why we have these issues, or why you can find outside on the client side some issues like that, because not all installation in the field are installed like the PI guidelines will describe it. So I will show you now in this presentation what you can find in the guidelines to protect yourself against some issues like that. But before we go so deep inside in the guidelines, I will give you a small overview of PROFINET. I think all of you know, in a PROFINET network, we have a controller, we have switches, we have PROFINET devices, we have a cyclical communication. So it means that all devices communicate deterministic to the SPS or to the PSC. And how you can manage that, or how you can configure it, that the devices will send some information to the right time to the PSC. If you go in the hardware configuration, you can configure each device, the update time and the watchdog time. What means the update time? For in this example, you can see we configured this device with an update time of 4 milliseconds. That means this device will send every 4 milliseconds information to the PSC. and the PLC will send every 4 milliseconds information to this PROFINET device. So this is a normal input-output communication, and this is how it works in PROFINET. The watchdog means how many times the PLC or the devices will wait for this information. For example, if the PLC don't get information in this node and will try to parameterize this node again. From the other side, the device will do it on the same way. So if the device don't get in 12 milliseconds new output information, the device will drop off. Yeah, and this is what you describe, or what the watchdog time describes. Important is, please don't touch the watchdog time if you don't have a condition monitoring system, because this 3 times of the update time is normally complete enough for your process. Important is that you don't use not the automatic mode from the update time. Recommended is to configure it by your own. And here the recommendation, how do you configure the update time, is that you measure your PLC cycle time. For example, your PLC cycle time is 20 milliseconds. And after that, you divide it by 2. And when you say, okay, if I have 20 milliseconds cycle time, you divide it by 2. And when you get 10 milliseconds, so it means now you configure your update time around about 10 milliseconds. 10 milliseconds are not possible. Now you can change it, for example, to 8 milliseconds. And when you have a good situation for your process, that means you are double so fast as your PLC. So if you have an issue, you still have protection, but your system has not so much traffic, and you will see in the next slide how important it is to have less traffic in your network. So this only for an overview over PROFINET. So, and now we have different kind of quality parameters. How I said, you can look to these values on the logical side and on the physical side. So, for example, for the physical side, we have quality values like line depth, cable category, American wire gauge, EMC, and shielding. And on the logical side, we have the jitter, frame gaps, error telegrams, load ratio, and the net load. And now I will explain what it means and how do you can find it out, or what issues do you get if you don't follow these quality values. Okay, let us start with line depth. Your line depth describes your cascading of your topology or your devices in your topology. So, but you have to know how do you count it. And for example, this device next to the node number 5 has a line depth of 9. And how do you count it? You can count the devices from between the PLC and the last node. So, for example, now here I can show you directly. For example, this device has a line depth of 4, because between this node and this node we have 4 devices. 1, 2, 3, 4. So this device has a line depth of 4. Why is it important to know? How I said, each device sends information to the PLC. That means each device creates net load. Is your net load too high in a line? You get issues, or better to say, the device getting overloaded. And it's possible that this device will discard frames. And because of this discarding frames, you get a stop of your plant. So, for example, if your PLC runs with 1 milliseconds, you can handle a line depth till up to 7. If you have a line depth, for example, now here with 9, you have to change your update time of these devices in this line to 2 milliseconds. So, in it, yeah, here you see it again. If you have 1 milliseconds, you have a line depth, or your maximum line depth is 7. If you have, for example, 2 milliseconds, your maximum line depth is 14. So if you double your update time, you will double your line depth. And so you can easily calculate by your own. The next things are a lot of cable values. So important is, for example, if you have a normal 100 megabit data transmission of your PROFINET system, when your PI design guideline will give you the recommendation for Cat5 cables. If you have a gigabit transmission, when we use Cat6, normally the recommended American wire gauge is AWG22. The maximum EMC current on the shield or leakage current on the shield has a maximum value of 40 milliamps, and your shielding on your cable is described as SFUTP. That means shielded, foil shielding, and a unshielded twisted pair wire. So these are the normal information or quality values for your cabling. And this is what you can find out if you, or by the description of your data sheet of your cables, or you can measure by your own, or you look to the description, to the marks on the wire. Okay, but more important are the logical values. For example, the jitter. So what describes the jitter? For example, if you configure your system now like that you transmit every 4 milliseconds in information to the PLC, the jitter describes how accurate is this transmission time to the PLC or from the PLC to the node. So if you configure it 4 milliseconds, you want every time 4 milliseconds. But sometimes I say every time PROFINET is like a human. So sometimes the frame comes earlier or later. And this accuracy is called jitter. For example, if you have old devices, so your devices are aged or your network is aged, the jitter will increase. Or for example, you have additional TCP/IP transmission. Each device has to check each frame. TCP/IP frames are normally very large, and this means that the devices needs more time, and that means your normal cyclical frames will come later, and this is why you get jitter. So jitter is a very nice quality value. With jitter you can find out if your system are aged or how accurate are your frames reach the PLC or the nodes. So very important value. Okay, the next thing is the telegram gap. So that means if you have, for example, an error frame, or for example, you have too much net load, how I said, the devices will by overload discarding frames. So, or if, how I said, if you have an error frame, a destroyed frame, the devices will discarding this frame. Because of your cyclical communication, and if devices discarding frames, that means you get a frame gap. So now if you remember on your watchdog, if you have 3 missing frames in a row, your plant will stop off, or you go in a safety mode, so in safety stop. And so if you have 3 frame gaps in a row, your plant will stop. Okay, this is the same way you have it in the slides. Yeah, how I said, the watchdog is normally, or common configuration is 3. So if you have 3 missing frames in a row, you get this stop. Error frames. Yeah, I think this is clear. This is closely to the normal Ethernet networks. So if you have error frames because of EMC, because of bad devices, because of reflection, because of your bad installation. When you get error frames and all devices will checking these frames, and if you have a broken frame like that, the devices will discarding this frame. And then you have again a frame gap. So load ratio. What means load ratio? Load ratio means how many, or is the comparison between PROFINET frames and Ethernet frames. So important is in a PROFINET network, because of your cyclical communication, you have a lot of PROFINET frames. And now you have to look how many PROFINET frames I have in my system and how many Ethernet frames you have in your system. Because if you have a lot of Ethernet frames in your system, how I said, it could be create jitter or it could be create net load. And this will disturb your cyclical communication, your PROFINET network. And this is why it's important to look how is the ratio between these both frames. And here the recommendation is 100 to 1. So that means 100 PROFINET frames and 1 Ethernet frames in this measuring time. So, and the last quality value is the net load. And here you can find, or here you see what could be the reason for net load. How I said, it could be your cyclical communication and it could be your non-cyclical communication, like this camera in this example. And all these devices will create net load. To get a feeling how many net load create one PROFINET node, you can say one PROFINET node with an update time of 1 milliseconds will create around about 0.6 till up to 1% net load. Now, if you follow the PI design guideline, you will read that the maximum recommended net load in your system is 20%. If you are over 20%, you have to do something, or you have to look what is the reason for such a high net load. And now be careful. For example, if you have a Phoenix PLC, if you read the data sheets of a Phoenix PLC can only handle 10% net load. So this is why you have to look how high is your net load in your system and if the devices can handle this. The good one is if your devices can handle the net load, you get frame gaps or you get a high jitter value. But this is what you can find out very easily with measurement tool. In the slides, I put you every time the slides on the PI design guideline so that you can read it directly also if you would like from the guideline itself. So maybe some additional words to the net load. You can decrease the net load if you don't connect TCP/IP devices directly in your network. The recommendation is normally to connect TCP/IP devices directly on a switch because a switch can forwarding frames to the right port. And the other thing is if you want to decrease the update time of your or if you want to decrease your net load of your I/O devices, you have to reconfigure your update time, because if you decrease your update time, you will decrease your net load of your cyclical communication. Good. Here again, you have the whole overview of your quality values, so you can use this to compare it with your plans if you like, or with your plannings. So, and now I want to show you how you can measure it. Your topology, you can measure it very easily with some scanning tools. For example, you can use ProScan Active or a PROFINET Inspector. This both measurements tool can analyze your topology. So this software or these devices will ask over SNMP or LLDP information. So each device in a conformance class B knows their neighbor. So with scanning tools like that, you can analyze your topology very easily, and it's every time up to date. So you get the right topology to this time that you measure. I will show you later a small example how you can find it out. The other things how you can find out if you have the right cabling in your network, or is your cabling have a good quality. You can measure it with a CAT certificator like that. This is from Fluke, the EtherTest version 5, or you can measure it with a smaller cable analyzer like the ProLine test. And when you have to check each cable by your own, and this line tester or CAT certificator will give you information if your installation is right or not. How do you can find out the EMC issues? For example, if you measure or if you want to find out your EMC situation, or if you want to find out your EMI interfere or your EM electromagnetic interference in your system, you can measure it with simple clamp meters. You can find on the market different clamp meters. For example, here you have the MWMZ. The MWMZ can measure the impedance. So it means you can connect it over a cable, a grounding cable, a shielded motor cable, or a shielded data cable. And this clamp meter will show you the impedance and if the cable is connected or the shielding is connected on both sides. If it's connected on both sides, you get, how is it, the impedance, and you can compare it if it's good or is it bad. Another clamp meter what you can find on the market is the normal leakage current clamp. For example, here the LSMZ. With this one, you can measure the current. And here the recommendation from the PI and also our recommendation is that you have to be around about by 40 milliamps. If you are over 40 milliamps by new plants, you have to do something. And if you have more current as 150 milliamps, you don't have shielding protection anymore. So for example, if you measure your shielded data cable now, for example, the PROFINET cable, and you measure over 150 milliamps, that means in this situation, you don't have shielding protection anymore. And it's possible that you get problems because of your interference in your system. So this is how you can find out these values. I say it again. Line depth, the topology, you can find out with topology scanner, for example, the ProScan Active. Your cable category, your shielding, you can find out with cable certification devices or with a normal cable tester, and your EMC situation you can measure with clamp meters. That makes it easy, and it's very easy to do it by your own. Now we come to the logical values. The logical values need special hardware. You cannot read it out from the PLC. This is not possible because the PLCs don't give you a network overview. For this one, you need normally measurement tools like the PROFINET inspector. If you look to the guidelines, you can read out that you need a measurement point or a tab, or this is recommended that you have a measurement point between controller and the first device, for example, your switch. Between your controller and your first device, you have a measurement point or your measurement tool by itself. And if you are inside this connection, you can find out all these quality values very easily. How it works, I want to show you. For example, now we have here a small PROFINET installation. You can see here we have the PROFINET inspector, the measurement tool installed, and we have some I/O devices. Let us go to the website or web interface of our switch, of our inspector, and we'll see here the inspector is error-free since 49 minutes. You can go to network overview, and the inspector will show you easily all quality values in the system. You see if you have drop-offs of nodes, if you have restarts, if you have normal diagnostic frames, PROFINET alerts. How is your update rate in your system? How is your transmission clock of your PLC? How is the jitter, frame gaps, and load ratio, all the things that you hear before. So if you get now an issue, let me try something. So you get very fast information about it. First of all, you see, yes, something is happening in your system, and you see what kind of issue do you have now. We get now an alert in this situation, and now if you want more details about this issue, you can press here on this bell, and now you see we have a diagnostic messages that from the Siemens IO2, and here you see it is a PROFINET diagnostic with low priority. We have a pull of slot number 2 on this timestamp. This is how it works. The inspector can analyze all quality values and all normal situations in PROFINET, like diagnoses, like drop-offs, like restarts. And every time the inspector will show you what happened, which device, and on which time. Let us go back to the first slide. Sorry. You can go also to the device overview. And here in the device overview, you get a live list of all devices in your plant. And here the same, you will see in the history what's happened on which device. If you press on this device, again, you can see very easily what was the issue. And so you can start with your troubleshooting. The problem on bigger plants is every time, now you know which device, but on big plants, huge plants, you don't know where is this device, or maybe it's not easy to find out where is the real issue if you have more as one device that is interfered by this problem. In this case, how I said, you can use topology scanner like ProScan Active. For example, this is now ProScan Active. ProScan Active can measure you the whole topology and will show you what devices do you have in the system, and you see what kind of installation do you have. For example, here we have a plastic optical fiber installation, so it's a fiber installation, and you can find out here if the devices support this information, the line length. All information what you can see here in the software is not measured by the software. The devices send this information over SNMP to ProScan Active, so the software only asks for these devices, and if the devices support, for example, to measure the cable length, you get the cable length. If the devices don't support to measure the cable length, you don't get the cable length. So if you don't see some information, is normally not a problem of your topology scanner, is a problem of the devices itself, or the devices can send you this information. So what do you see as well in this software? You can go to statistics. You see if you have some issues in your system. You get information about PROFINET devices, missing devices, duplicated IP addresses. But my important function of the software is the version statistic, because the recommendation from the PI is that all devices from the same type have to have the same firmware version in your system. So if you have a lot of ET200, for example, in your system, ET200 have to have the same firmware. This is what you can test very easily with this software as well. You can scan it automatically, and the software will show you in red coloring if you have older firmware versions on your devices or differences. So what else? Connection statistic, how I said, a lot of devices will discarding frames if you have a lot of net load, so the device is overloaded, or if you have error frames. In this situation, the device will discarding frames. Because of this discarding frames, you don't get the diagnostic information. How I said, PROFINET don't has a network diagnostic. PROFINET has a device diagnostic. So if you have problems with the device, you get a very nice diagnostic. But if you have network issues, you don't get a diagnostic. In this situation, the devices know they're discarding frames, but they don't send this information to the PLC. The software ProScan Active can analyze the system and ask all devices, did you discarding frames, and how many discarding frames you discarding on which port. So if you have discarding frames, you get here a table, and in this table you see which device, which port, and if it's error frames, discarding frames. So is this because of overload, or is it because of some interference? But how I say it, the important thing, if you have now some problems in the system, you want to know where are these problems in my systems. And here you see in this software, you see some green bar charts, and this green bar chart shows you the situation as you measured or as you analyzed with ProScan Active. And now in this situation, every device was green. But if you look now to the inspector, we know something happened in the past. And now we want to know where are these issues in my topology. In this case, you can go to scan, you can make a comparison. We press on this comparison, and now this device or this software should look for changes. For example, people change the port, people change devices, people replace something. All these things will analyzed by ProScan Active, and the software will show you these changes in this overview. And now we see it here very fast. We see here now it's colored yellow, so we know everything is green, and we see something is changed with the topology. So you see here this wire is missing, and we get a new installation over this one. So this also is missing, so we get a new installation over this one. It looks now a little bit strange, but how I said, this software will show you all your changes in your system. So if you want to know what are the reason of this issue, first of all, you can find out, okay, here you see the wiring was changed in the past. And for example, why you have here yellow bar charts, you can press on the device, you can go to the inspector overview, and you see here now we have low priority alarms. So this software helps you to analyze, how I said, your topology, and to find out in your topology what or where are the issues and what changed over the time. For example, my first scan was made from the cable installation guys, and the last scan is made by the maintenance guys, and now the maintenance guy says, oh yeah, something has happened. We some people changed the switch, so we changed the wiring, and we have maybe some issues on this device. And how I said, the nice thing, if you have a big plant and now you have net load issues, or now you have discarding frames, you will see in this topology very easily, okay, till this device everything is fine, and after that now it's starting with our discarding frames, with our telegram gaps, and now you know, okay, all these three devices has some problems with frame gaps. So that means we have an issue in this part of the plants. And you get this information before you get a stop of your plant if you do some measurements by your own. Okay, this to the ProScan Active in the inspector. The nice thing for the inspector itself, you don't need software, you have a web interface, and over this web interface you can analyze, how I showed you, your network very easily. And if you like, you can also do some switch analysis, and if you like, you can also scan for topology. You can also create a report, so that you get with one press on a button a report, and this report shows you the actual situation of your network. Okay, this to the inspector and to ProScan Active. And now what I want to show you are the condition monitoring. So the inspector is normally designed to do long-term measurements. You can use this inspector or measurement tools like that also for troubleshooting. So in this case, you don't have a history. You have to install the inspector, now waiting for the issue. If you get the issue, the inspector show you all your issues, what you have, and when you compare it with the topology, on which position your issues started, like net load, error frames, or frame gaps, or your jitter. You can do this measurement also over long term. So in this case, the inspector can give you alerts before something happens. And this is normally the idea of the inspector, to use this as a long-term measurement tool. And the nice thing is, how I said, you get the alert before something happened because of your watchdog. The inspector will analyze your frames and will tell you, oh, now you have some error frames or you have some frame gaps in your network. And if you don't do something, you will get a stop of your plant in the future. For example, in our statistics, we find out if you work with the PROFINET inspector, normally you have 2 months time before you get the stop of your plant. So the inspector gives you 2 months time to look around your plant, to thinking about the issue, and maybe to do the troubleshooting before you get a immediately stop of the plant. And if you do something and the inspector or other measurement tools shows you your diagnostic effort, you can increase your life cycle or your healthy of the plant, and in this case you increase your life cycle of your plant. So how you can do it, what I said, you can do it very easily with measurement tools like the inspectors. We have these inspectors for PROFINET, Profibus as well. And you can do it with managed switches. And if you follow the guidelines of the PI, you find out that all PROFINET installation have to have used switches, managed switches. So this is very important. So, but if you have managed switches in your plant, the managed switches can send you first of all diagnostic information if something wrong with the device itself. And the nice thing is, if you have managed switches, you can ask over SNMP for port statistics. And this port statistic will tell you if you have some error frames, how is your net load, how is your how many discarding frames do you have on which port, and all these things you can analyze very easily with management tool for networks. And we use, for example, our ProManage, and this ProManage asks every 1 minute all switches and all inspectors for the actual situation in your network, and will show it you in a graphical overview. Additional information for switches, for managed switches, if you have up-to-date managed switches, you can measure today with this managed switches also your cabling. So you can find out, is your cabling okay or is your cabling bad with managed switches. And also managed switches supports EMC measurements. So if you have, for example, now this ProMesh series, you can measure your EMC environment. And if you have too much shielding current on your cabling, these devices will send you a diagnostic information and will tell you something is wrong with your shielding current in your plant. Now, this is what you can do today with managed switches. And so if you look to actually plant designing, we have an OT area, we have an IIT area, and we have the IT area. The good thing for the IT area is they already work with managed switches and work with management tools like ProManage. So, but the problem is, in the most of cases, the OT and the IIT, your whole network, don't work with tools like that. But how I said, this is normally very easily to upgrade. You can work with measurement tools, or you can work with managed switches. And if you have managed switches in the OT area or in the IT or IIT area, then you can analyze all these networks your whole network and your planned network very easily with a management software, and this management software will tell you in your IIT area everything is fine and your OT area is everything fine. Or for example, if you have problems, this software will tell you what is the problem and where is the problem. Also, ProFinet, for example, has topology functions. So if you use inspectors or managed switches, you can find out over ProFinet what is the issue and where is the issue. So this was a fast overview of PROFINET and troubleshooting and quality values. I know the time is very short, so normally for this information, yeah, I have a 2-day training for PROFINET. So now I try to put all or a lot of information in this 1 hour. So I know it's a lot of information, and I hope you understand everything very well. If you have some questions, you can ask me, yeah, now if you like. And yeah, what I can also recommend for you, reading the guidelines, the design guidelines, and also the commissioning guideline. You get all this information what I presented now to you in these guidelines. Okay, the guidelines don't tell you something about measurement tools, only about the quality values. So, and then I wanted to show you today also the measurement tools, what you can use additionally to these guidelines to find out if it's, yeah, underneath or under these values, or if you have some, yeah, interference in these values. And if you have some interference, what could be the reason for this interference? How I said, if you have a jitter, it could be aging, and it could be too much TCP/IP transmission. If you have net load, the same, too much TCP/IP transmission or a very fast update rate. If you have error frames, it could be EMC, EMI, it could be broken error cables, it could be reflections. And if you, what we are missing, jitter, frame gaps, error frames. If you have discarding frames, it could be a reason for net load and error frames. Good. Do you have questions?
I don't have a question, Stefan, but a quick remark. Very well done, very insightful. Thank you very much. And I'll definitely welcome any questions from anyone in our attendance list.
Hi, Stefan. This is Greg from IS Systems. I have a questions. For in terms of like update times, is there a difference between an Ethernet and fiber? Because some fibers they offer sort of a higher speed.
Yeah, can you hear Gregorius there? Can you hear Greg?
Yes.
Okay, how I say it. Important for me is that you work with the guidelines, because in the guidelines you can find a lot of information about PROFINET, and you will find the quality values. And additional, how I say it, measure. You can measure by your own. The measurement tools are not complicated. I hope you find it out with me together today. So normally all quality values can measure very easily with clamp meters, with a measurement tool, with topology scanner. But you have to measure that you find out what is the quality in your system, and that you can protect your system before you get a drop-off of your nodes. Good, this is my recommendation for you. How I said, it was a lot of information and in a very short time, but I hope you understood it very well. And I think also Fritz will share with you the slides that you can read it by your own in the future.
Yes, and the recording will be shared too. Greg, did that answer your question? Because I didn't quite get your question either.
So I'm still some minutes here. So if you want to write something, you can write it in the chat, or you can ask me directly.
I think the chat, I closed the chat to begin with, but that is fine. Greg, go ahead, mate. Ask your question again.
Yeah, just the difference.
I don't know, Fritz, if you want to say something additional, or
Now, I think we have a miscommunication here. Greg would like to ask a question. Go ahead, Greg.
Yeah, so my question is, if I'm using a fiber cable instead of an Ethernet cable, would there be a difference in terms of like, you know, the line depth, or, you know, this like the
Good.
all the speed
Okay.
measurements?
How is it? If you don't have questions, if you like, you can write me also an email and you can ask me directly. In this case, maybe I can.
Greg? Sorry, Stefan. Stefan, I think we have issues that the sound from our participants doesn't come through. Can you hear me?
I will go back to this slide. So
I can answer that too for you too, though, Greg. Can you hear me, Stefan?
Yeah.
Stefan, can you hear me?
Doesn't look like he can hear you.
I think his sound is off. Let
Good.
me shoot a
So
message.
if you like to, I know. How is it? If you like to send me your question in the future, you can write me directly an email. You can send it to Fritz, or and Fritz will share this information and this question to me, and so I can also answer your question in the future. So I thank you for your time, and how I said, I hope you get this information what you needed from this presentation, and maybe we will see us in the future. Thank you very much. Have a nice evening. Now my day is starting already. Now it's 8 o'clock, and yeah, how I said, have a good time and measure. Bye.
Thanks, Fritz, for organizing this. Appreciate it.
Thanks. You're welcome, guys. I think we had a bit of an issue that the sound was off on their side. Quickly back to your question, Greg, though. So every switch causes a delay, and with normal switches, it depends on if it's cut through or if it's store and forward switch. So the delay is dependent. Cut through switches are faster, around 7 microseconds. If you go fiber optic, you still have a conversion, obviously, from copper to fiber optic. That conversion takes time too. So I would take any fiber optic converter as part of the line depth and count it as a device, would be my short answer for that.
Thanks, Fritz.
You're welcome. And to be honest, don't use 1 millisecond for PROFINET networks unless you really have to. Siemens defaults to 2 milliseconds. Even that is rather fast. Most applications don't need it. So you can do a lot of good with your design and the consideration of what Stefan presented here today. And if anyone else has questions, I at least can hear you, and I'm happy to answer what is within my capability. But if not, I say thank you very much, everyone. I hope it was interesting. I certainly got some new stuff out of it. And we'll leave it there. I'll leave the mic open for another minute, and otherwise we'll see you hopefully soon for another webinar that will be organized by our regional Profibus Association, because we have more planned for the rest of the year.
Thanks, Fritz. Much appreciated. Take care.
Most welcome. Thank you.
Thank you.